So today we're going to continue working with box plots. Yesterday you watched some Khan Academy videos and you might have learned that box plots have another name, and it's box and whisker plots. And that's because when you draw one correctly, it looks a little bit like a box with whiskers coming out of it. So we're going to work out of your book today. So if you could open to page 465. There's a lot of vocabulary here that you're going to want to really understand. You should also have a calculator with you as we are working with data. So first of all, a box plot is a display or type of graph that shows how the values in a data set are distributed, how they're spread out. And so we need some different values in order to draw a box plot. The least value, which is also called the lower extreme, if you want to add that in. That's the least value in the data. The greatest value in the data is called the upper extreme. You may hear both ways of referring to the same thing. Okay, the lower quartile is the median of the lower half of the data, and the upper quartile is the median of the upper half of the data. Now the word quartile has as a root word quart. Quart, if you think about a quart, there are 4 quarts in a gallon, there are 4 quarters in a dollar. It has to do with fourths. Sometimes we use the word quarter to indicate 1/4. It's another way of saying 1/4. So what we're doing is we're taking all of our data values and breaking it into 4 groups. So we're going to jump to the next page and work on this number 2 problem. But you will need, well, I guess there's room, we can do it here. We're going to write the data out so that we can find the median in the upper and lower quartile. So it says under your turn here, make a box plot for the high temperatures shown. So we're referring to this chart here that has a bunch of temperatures. So the first thing we need to do, because we're working with median, is always list the data from least to greatest. So I'm going to do that right here. So if you want to just pause the video for a moment and write those values in, please. Okay, so here's what I did. We have 12 data values, and I listed them as 75, 78, 78, 79, 80, 83, 84, 85, 88, 89, 92, 94. So hopefully that's what you have. So we have 12 values, which means that the median is going to be between 2, right? Because there's an even number of values. So let's work our way in, starting from the outside. Come in 1 data value at a time from the left and from the right. I'm going to put a box around the 2 that are in the center, 83 and 84, which means that the median is going to be 83 and 5/10. And that's because that is the value that is halfway between 83 and 84. So I'm going to estimate where 83 and 5/10 is. So this is going to be 84 here. So 83 and 5/10 is going to be about here. Now sometimes you're going to see that these box and whisker plots are done above a number line. I'm going to do it on the number lines just so we can kind of see, maybe see a little bit better. Okay, so I'm going to put a dotted line in between 83 and 84 on our list of data values. 83 belongs in the lower half and 84 belongs in the upper half. And now what we're going to do is we're going to find the median of each of the halves. So if we start on the lower half with 75 and 83 is the outside, we go in one, we go in another, and we have 78 and 79 are the 2 middle values. So that will become our lower quartile, and it would be the halfway between 78 and 79, which will be 78 and a half. So again, I'm going to, 78.5 is going to be about right here. Just going to draw a point there. Okay, we're going to do the same thing now on the other side in the upper half. So that 84 is part of the upper half. And we're going to start from 84 and 94, work our way in. And our two middle values are 88 and 89. So our median would be halfway between them, which would be 88 and 1/2, which will be right about there on our number line. Okay, so now the box part of this comes from drawing a box where the lower quartile, which is 78.5, and the upper quartile, which is 88.5, on the outside edges of the rectangle. Okay, now the whiskers are connecting the upper and lower quartiles with the upper and lower extremes, or the lowest value and the greatest value. So the lowest value on our list of values is 75. So if I put a point at 75, then we just fill in a straight line from 75 to 78.5. And then on the other side, our greatest value is 94, so we put a point on 94, and then we draw a line. So the box is this part, the whiskers are the two lines that go to the upper and the lower extremes. Okay, now I want you to notice something. I'm going to get a different color pen here. But just going to draw dotted lines again. We started here with the median falling between 83 and 84. And then the median of the first half fell between 78 and 79. And the median of the second half fell between 88 and 89. So I want you to look at how many data values fall between each of these dotted lines. 1, 2, 3. 1, 2, 3. 1, 2, 3. And 1, 2, 3. So our data is distributed so that there are three data values on this part of the chart. There are 3 data values on this part of the chart. 3 here. And then 3 again on the last part of the data chart. So we took all of the data and grouped it so that 25% of the data falls within each of these ranges. That's why they're called quartiles. So let's go back up to this reflection question above. And it wants to know what percent of the data values are included in the box portion. Well, the box portion is this, right? That's what the box of Box and Whiskers. And you can see there are 2 25s there. So 50% of the data, that means 50% of the data values fall within that box. And then what percent are included in the whiskers? 25% here and 25% here. So jump to page 467 and let's look at finding the range. Now we talked about the range last week, but haven't really worked with it yet. The range is really just another measurement that describes the spread of the data. And really all it is the difference between the greatest value and the least value. So here in our example, we show the age of players on 2 professional baseball teams. And it wants to find the range of each set of data. So we have Team A with a bunch of data and Team B with a bunch of data. So the first thing you have to do is order them from least to greatest. So just like with median, arranging the data in this order makes it a lot easier to work with. So on Team A, you can see the youngest player is 21 and the oldest player is 39. Range is simply the distance between them. So we subtract 39 minus 21 and we get 18 years. 18 years is the range of ages for Team A. Team B goes from 21 to 31. So Team B has a difference of 10 years. So the range in the data is 10 years. So what does that tell you? That this team is much more similar in age than this team. Okay, so your assignment is on page 469. I'd like you to try number 9, 10, 11, and 12. And then on the next page, number 4 at the top. And then tomorrow we'll come back and take a look at how you did. Okay? Good luck.